machine learning using the Spark. So before going to start, let's start the introduction of the machine learning. It's now time to begin with some machine learning section of course. This introduction section will discuss general introduction of machine learning and show the how MLlib library works for the machine learning. Most of machine learning section we would have suggestion of reading assignment, basic theory lecture, documentation walkthrough, more realistic custom code example, and consulting project solution. And in this course, the consulting projects are looser, more the realistic project for you attend with the skills you just learn. A data set, some backgrounds, and the problem is described. You are free to solve the however you want to solve the problems. If you prefer more guided approach problem, that's totally okay with me. We have custom code example before the consulting projects, plus you can treat the consulting project solution additional code along with problems. Because different students have a different backgrounds in a math, we keep the mathematics behind the machine learning algorithm light. If you are interested reading the more about the machine about the math behind the algorithm, we will discuss and we will using the introduction to statistical learning by the James as a campaign books. It's freely available online. A student who want to mathematics theory, you should do suggest reading assignment that will appear for each machine learning section. Otherwise, feel free to watch introduction theory lecture for the fundamental from YouTube. First, suggested reading assignment, read a chapter 1, 2 and get some background of machine learning and then start. So what is the machine learning? Machine learning is a method of data analyzing that autonomous analytical modeling building using algorithm that iteratively learn from data. Machine learning allows computer to find hidden insight without being explicitly programmed where to look. These are the some of example of machine learning: recommendation engine, web search engine, fraud detection, credit card fraud detection, housing price, email spam filtering, financial modeling. So before going to start, what is the machine learning process looks like? This is process look like before starting. It's have data before starting the machine learning. So we should have some kind of data. Or most of company they start machine learning, they don't have data, so initially they have data in form of SQLs or form of CSV. So we should get all these data and do data cleaning, some kind of data cleaning, remove the null values or fill with the null values. If you have timestamp column, you want date on year column in separates, and divide data into two forms: test data and training data. So test data basically and training data. So we in test data, training data, we have some kind of input and output. We know this would be output, so based on that we will train our model and check the efficiency of our model. If it looks fine, then it goes to the production. So before going to start machine learning, so let's discuss about the machine learning. There is two kind of machine learning, so we are going to discuss the supervised. Spark MLlib mainly designed for supervised and unsupervised machine learning tasks, with most of algorithms falling under those two categories. Let's discuss them in more details and describe how they are different. Supervised learning algorithms are trained and using label example such as the input where the desired output is known. So we have input and output, past historical data, and based on those data we need to find in the future what would happen. For example, piece of equipment could have data finds label either failed or fail or running a run R. So these are the first data, so we need to based on the future data we need to predict whether it would be fail and run. Learning algorithm receive the set of input along with the corresponding correct output. Algorithm learns by the comparing its actual output with the correct output, find the error. It's the modify the model accordingly. So we will check the data and whether its output is matching. If matching, then it's fine. Otherwise, In supervised machine learning, through the methods like classification, regression, prediction, and supervised learning use a pattern to predict the value of label on additional unlabeled data. Supervised learning is commonly used application where historical data predict likely to future events. For example, it can anticipate when the credit card transactions are likely to be fraudulent or which insurance customer is likely to file the claim. Or it can attempt predict the price of the house based on different features of house for which we have historical price data. And now let's start. What is unsupervised learning? It's used against the data that has no historical label, only we have a features. Feature is represent a number of input fields which we use to predict the data. The system is told the right answer, the algorithm must figure out what is being shown. The goal is explore the data and find some structure within this data. For example, it can find a main attribute that separate customer segment from each other. Popular technique include self-organizing maps, nearest neighbor mapping, k-means clustering, and singular value decomposition. One issue is that it can be difficult to evaluate results of unsupervised model. Machine learning takes time to learn. Be patient with yourself and feel free to post your QA form. No one course can be reference for all machine learning topics, but I'm always happy to point you in right direction. Machine learning with Spark. So we are going to learn machine learning with Spark, Python and Spark. Spark has its own MLlib for machine learning. The future of MLlib utilize the Spark 2.0 DataFrame syntax. One of the main using MLlib that you need to format your data, so eventually it just has 2 columns, features and labels for supervised, and for unsupervised it's only features. This requires little more data processing work than some other machine learning libraries, but the big upside is that the exact same syntax work with the distribution data, which is no small feat for what's going to under the hood. When we working with the Python and Spark MLlib, the documentation example is always nicely formatted in Apache Spark. However, we will have our own custom example that have a massive more realistic data. We will also have a consulting project which set you loose on real world data project with the data sets and problem to solve without explicitly telling you what you to do. The use part of learning MLlib is getting comfortable with the document now. Day by day it's getting comfortable, being able to master the skill, finding information, not memorizing. It's the to key becoming the greatest Spark in Python developer. Fortunately, the Spark MLlib document is quite good and we will constantly teach you how to refer it during the